All right. So this is 4.3a, and you all were asking about these piecewise functions that looks like this, and I've just copied this out of the Hawks. And the question gives you a function, and then it says 2x minus 2 if x is less than or equal to -5, or negative 3/4 x plus 3 if x is greater than -5. And all this question is asking for is to evaluate f of x at x equals -5. So we're trying to find where what is f of -5 is basically what we're trying to find. So you come up here, you're going to use one of these. You have to decide which one of these do you use to plug -5 into. And to do that, you have to look at your restrictions over here. If the x value is less than or equal to -5, use the top. If the x value is bigger than -5, use the bottom equation. Well, -5 is actually equal to -5. So I'm going to use the top equation. So I say 2 times -5 minus 2 is -10 minus 2, which is -12. So f of -5 is -12. Simple enough. Then the next one, let me type it in real quick and get the next answer. So then it asks for, let's say, f of 3. So which one do you use if you were trying to find f of 3? Well, is 3 bigger than -5? Yeah, sure it is. So it's not less than -5, it's bigger than -5. So we're going to use the bottom one. So 3/4 times 3 plus 3. That's a -3/4. Okay, so -3 times 3 is a -9/4 plus 3. Now, how many quarters is in $3? How many quarters can you put into 3 holes, basically? Well, 4 times 3 is 12. There's 12 of them. 12/4. 3 is the same thing as 12 divided by 4. Same idea. Now, since I had the same denominator, I just add across the top, -9 plus 12. It'd be 3, wouldn't it? It'd be 3 left over. 3/4. So f of 3 is 3/4. The other situation that you're dealing with here on Hogs with these piecewise functions is the actually graphing one. So let me find one here where you have to graph one. And it says here that r of x equals, you get this little bracket here, -7x minus 21 and 1/2 x squared. Now your restriction happens at x less than or equal to -3 and x greater than -3. Well, you want to actually graph this thing. And I'm going to graph it by hand first, then I'll kind of walk you through what Hawks asks for. But first off, I want to get a XY coordinate plane here. So I'll do this. So we want to graph this on by hand. So here's the idea, and I'm going to use a pencil for this, I suppose, because I need to erase some stuff off. Here at -3 is kind of like a boundary line. So -1, -2, -3. I'm going to just draw this imaginary dotted line here. Pencil. It's like you're drawing a line in the sand. Okay. Now, the graph has to carry both of these on here. This XY coordinate plane has to have both of these on there. But the trick is you can't have it cross this side here. So, for instance, x is less than or equal to -3. Less than -3 is to the left, right? Less than -3 is to the left. So this guy on top is going to be graphed on the left side of this line, and only on the left side of this line. This other guy is x is greater than -3. X is greater than -3. Well, the x value is greater than 3 goes to the right. So the 1/2 x squared has to be on the right side. The -7x minus 21 is on the left side. Now that parabola, this is going to be a parabola because it's x squared, and I'm just kind of roughing this in here. This is not exactly what it would look like. Just throwing it in here, okay? Then this negative 1/7 minus 20, so the x-intercept's way down here. I'm sorry, the y-intercept is way down here, and then the slope is negative. So it's going to be a fairly steep line too. But remember, it can't be on the left side, it has to be on the right side. So it would be something, you know, like this right here, coming in like this. You can't draw it down here. It's only on the left side of this imaginary line here. Now, there's an equal to on this guy with that line. There's an equal to's on it. So he gets a solid dot. And there's just a greater than symbol here. So he gets an open dot. He gets an open dot. Okay. Now that's drawing it by hand. To do this on Hawks, you have to select the graph, the general shape. So it asks for what is the general shape of the graph from negative infinity to -3 in bracket. From negative infinity to -3 is coming in from negative infinity up here -3. You're talking about this line. So you need to pick, you go to select graphs, and you pick the line that has the negative slope, and you pick it. It says that's correct. Then it's going to ask you to pick the other graph from -3 to positive infinity. Well, from -3 to positive infinity is going this way, which is the parabola. So you pick the graphs, you go to parabola, and you pick the one that's opening upward, and submit. Now you get to pick which one do you want, and the one that closest resembles it is the one you pick. And hit submit, and she's good. Now the one on the paper really doesn't look like that. It's my parabola is pretty close, but the actual line comes in a lot farther down than what I have it drawn as. I think it comes down like that. What we're worried about is that you have a general idea of what it looks like. Okay, so let's try one more. Let's see here. Okay, so this one says k of x is equal to 2 over x and -8/7 x. But now there's a restriction. If x is less than 1 and if x is greater than 1. So that's what we're trying to graph here by hand. So I'm going to put my little xy coordinate plane up. Make it a little smaller this time. And here you got two graphs, but now remember that there's an imaginary line here at 1. So there's 1. Imaginary line here at 1. That's not really part of the graph. I'm just putting it in there as an imaginary line. Now, to the left has to be one graph. To the right has to be the other one. Now, if x is less than 1, you're talking about less than 1, which is to the left. So that side should be the 2 over x graph. And to the right is greater than 1. So it's the -8/7 x. Now you got to think about, well, how do you graph these? Well, you remember what the 1 over x graph looks like. It should look something like this. You should have that on your paper somewhere or another in your notes. So that is what this guy over here, now the 2 just makes it either wide, it stretches it. Remember that it stretches when you multiply by a number like that. So essentially, you're going to have this part right here. Okay, that's all intact. And then you come down. But now it stops right there. You can't go across that line. And since it's just a less than symbol, it's an open dot. It's open. Now the other one's a -8/7 x. So the x-intercept, the y-intercept is at the origin. You go down 8 and over 7, so you're somewhere over here. So I'm just kind of roughing this in. There's no, so it has to look like this. Now remember, I don't want anything to the left of it, I want to the right of it. So really what you need is just this part here. And that's going to get an open dot as well because of this just a greater than symbol. So now what you do is you just pick this, you just pick your two graphs, and then at the very last step you pick the one that looks like this picture. And that's how you graph a piecewise function. If you need any other help, just YouTube Piecewise Functions.